Okay, welcome to 3311, section M. Okay, just make sure. Now, let's go over stuff related to the course administrative stuff, and then we talk about Java today, not iPhone. Okay, but we'll get there. Okay, so for those of you who don't know me from 2030 or previous courses, just call me Jackie. Feel free. I'm very informal. So, but if you're going to call me professor, other name, that's fine. Okay, and my office is upstairs. Oh, by the way, our lecture halls are very hilarious. It's actually a different lecture hall on different days, right? Today, Monday is here. Wednesday, Curtis Lecture Hall E. Please make sure you go to the right place. In case you don't see me, I could be that I go to the wrong place. You gotta grab me back, right? So make sure you go to the right place. Okay, my office is upstairs, Lassonde 2043. My office hour will be 3 to 5 p.m. and Wednesday and Friday. Okay, that's for this semester. And you can feel free to email me about appointments if you want to speak to me. And my advice would be speak to me as early as you can about issues. If you feel that you're not performing so well for the course, I advise talk to me as soon as you can. I will try to give my best advice to you. All right. Now, class protocol. Since we don't have a large class, it seems like, okay, but still, please, one person talking at a time. If you want to ask me a question, please feel free to interrupt me. I don't mind. Okay. 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 Just make sure you follow the policy. I don't need to be strict on you. Okay. Now, writing emails. Well, okay. I only added this slide from this semester. I tell you what, I'm also teaching 1021 this semester. I might get tons of email every day. So how do I prioritize my email? Please try to be nice to me when you write to me. Okay, I'll give you one example. Okay, so think of me as your colleague helping you to learn. All right. So, but you want to be polite to your colleague, right? This would not be so nice. Well, you don't tell me who you are. You don't really address me properly, and they simply say something that's wrong. Okay, that's not very nice. It's quite rude to me. Well, typically I might either delay my response or I will just ignore that. Okay, just be cautious about it. This will sound much nicer. Okay, you don't have to be formal, but just make sure you write it properly, the emails. Okay, this sounds a little bit thing I was be picky about. Okay, anyway, now course information. Let me just talk. There are many sources of website you have to go into regularly. Let me just talk to them one by one. You can ask me questions later. There is a course wiki site. So this is where we actually got a course forum. You have to subscribe to it. Okay, make sure you subscribe to it because all the questions related to labs, projects, or anything else related to the course will be posted on the forum on the wiki site. I'll go there in just a moment. And the wiki site, all the lab instructions and due dates and also all the other resources common to both sections will be posted here. I'll go there in just one moment. And then there will be 2 course Moodle websites. I would say we don't really use Moodle a lot. The only thing for section M, I will post the syllabus just for your convenience on the website, okay, on the Moodle site. You can log in to go to section M. And there might be, there's also another site for section M, it's only announcement. For example, I try to record my lecture every time. So after I upload the videos, I'll let you know. Okay, it's for section M only. And for section M and Z, so you also want to make sure you check the announcement regularly. So we might just make announcements sometimes. Okay, 2 Moodle sites. But the main source is the wiki site, which I'll just go now. And make sure you check your email regularly. Let me go to the wiki site and tell you what you should do. By the way, for those of you, there are 2 issues over here. For those of you who are not enrolled in the course yet, or you want to swap your lab session, either way, okay? I'm not the best person to talk to at the moment. You should really speak to our undergraduate office over there, that side over there, 1012M. Okay, speak to them for the first 2 weeks. Don't speak to me because I have no power as to enroll you into the course or swap your lab session. Now, for the course wiki site over here, what you have to do is this. So you go to the link, and then you have to first of all log in using your EECS credential. Okay, you should go to the bottom there, go to the right, and you say log in. So for example, I log in with my EECS credential, and then I want to show you its various places you should really go. Number 1, you will see there's a course forum over here. Okay, go there and make sure to subscribe to it, and then pay attention to it. any clarification about the labs, the projects, or the course will be posted there, the forum, okay? And what about the due dates? If you go to dates and grades, so this is the place where you see the important dates. But in my course syllabus, I also got information like that. I'll also go over syllabus with you quickly. Now, currently we have basically 2 due dates. For Lab 0 that has been posted before the new year, so that one is due basically already, but that one is not graded. But I'll suggest to you, you want to complete it as soon as you can. It will really affect your performance a lot for the rest of the course. And for lab number 1, which has also been posted, it will be due on Monday, January 21st, 2 p.m. Okay, strict. No extension. Since we got 2 sections, there'll be no extension. All right? Questions so far? Good. Now, about the due date, and there's also some schedule over here about what's going to happen for the rest of the semester. I'll also show you on the syllabus. The information is consistent, okay? Now, here is some assigned reading over here. I would say mainly you have to understand what I cover in the lecture. You can also just go over my slides, go over the sample source code I talk about, or any tutorial videos I make. That should be sufficient. I would say the required readings over here, it would be, if you want to get A+, we want to get an A, right? Which means you really want to gain 100% understanding. It's a very classic text on design contracts, object-oriented programming, object-oriented design. So that's something I would suggest you go and keep up with the reading, okay? And then I'll talk about grading scheme in just a moment. And what else on the wiki? So now, since you are section M, for my slides for section M, I don't post it on the wiki. I'll show you the link in just a moment. So now for SVN slides, this is for section Z, the other section. So we basically cover the same topics, but the order in which we cover topics might be slightly different. But you can feel free to refer to their slides as well, because eventually for the exam, all the topics will be common. Yes?
So going to the actual labs, we only need to do that if we have questions, since we can complete.
Yes, here's a good question. The question was, why would you go to lab session? Okay, so typically we try to release the instruction for the lab for you beforehand, so you can do some work. You don't expect yourself to finish the lab within 3 hours. It's not possible, okay? Just not possible. So what we want you to do is maybe spend maybe a good amount of time, maybe 5 or 6 hours before the actual lab session there. Let's say, for example, this Friday. Spend 6 hours on the lab 1, collect your questions. I will typically attend the labs on Friday for both sections. Maybe many of you saw me already on Friday. So you can ask me question there, or ask me even question on the slides. I'll be happy to answer. Since I got kind of limited office hour this semester, so you can definitely talk to me during the lab session. Now, of course, in the extreme case, if you're so competent, you can just finish the labs remotely and submit remotely. That's absolutely fine. The only time you have to show up will be the lab tests, which I will talk about, okay? But we don't take attendance. You guys are adults, right? So we don't need to take attendance, right? Good. Now, let me see. Okay, slide that for section Z. And if you go under labs over here, now this lab 0, I'll talk about lab 0 in just a moment, but this is lab 1 instruction. You have to run some command from the EECS terminal and then retrieve the instructions. Now, I want to point something to your attention quickly. So now, if you go under lab 0 and resources, okay, I know that many of you maybe have already finished the example about calendar, okay? Maybe most of you have, okay? If you haven't, please do that. And now, there's another tutorial series over here with 8 videos. So that one, I would urge you to also complete it as soon as possible. That one's over there, walks through many contents of the course, many design principles, many survival guide for IFO syntax over there in just serious video. All you gotta do is watch the videos and reproduce the software. I would say that will save you tons of time for the labs, okay? That's what I would suggest to you. Of course, the catch is they are very long, maybe about 6 hours or something. You know, if you spend a good amount of time, maybe only half an hour every day, maybe 1 hour every day, you know, you can finish that before this week. Okay, anyway, I cannot emphasize this enough. Finish that tutorial series. Okay, I recorded that, so I know it's very useful. Okay, all right, let's go back here. Now, there's another thing you want to do. So now you can see that under, again, the resources over here, we have a document called IFO 101, okay? So this is a document that we expect you to finish reading within the first 3 weeks of the course. That one there consists of many survival guides for design principles, for IFO syntax, for many, many things that we're going to talk about throughout the course. It would be your best interest to also go over these documents. There might be some contents which wouldn't make sense too much at the moment. That's fine. That's understandable. But at least you have some impression about them. So as we cover them in the class, it can strengthen your understanding. Okay, IFO 101 and also the tutorial series I just point to you. Questions? Good? All right, very good. So now, go back to the wiki. Let me see anything. Oh, office hour. So now, okay, you don't have to worry about Jonathan. He's from section Z. Jackie, so that's me, as I just mentioned to you. Now, we also have a very competent TA, William. He is also doing some office hour on your labs. If you're feeling too shy to talk to me, talk to William. It's Monday, 11 a.m. to 2 p.m. Okay, only 3 hours a week. But of course, if you cannot make it to William's office hour, come to my office hour or talk to me on the Zap, doing the lab. Okay. By the way, William's office will be Lassam building, 2nd floor, 2056. Okay. Just make sure you go there. Okay. All right. Any questions about the wiki site before I leave there? All right. Okay, so now that's about the wiki site, and let me see what else. Course syllabus, and it's available if you log into the Moodle and you can see the syllabus. Now let me go over the syllabus with you before we talk further. Okay. Okay, let's go to syllabus. Let me switch to iPad here. Syllabus. Okay, you will see exactly the same document, but let me just annotate that. So, okay, everything we have said already. By the way, this is my email, just in case you don't know. Jackie@eecs.yorku.ca. Okay? And let's go a little bit further. For course description, you can read it. And these are the learning outcomes we'd like to achieve by the end of the course. They look very ambitious. But you know, it's going to be exciting to achieve every one of them. But it wouldn't make sense to talk about it right now. Okay? So I'll talk about them as we go through the course. Now, required textbook. This is so-called OOSC2, as you see on the wiki site. This book is online. It's actually, if you go to the SVN slides, it's already made available to you under the copyright permission by the author. Don't distribute it in public. Okay? But you can definitely go through that. There's no need for you to purchase that. Okay, that's one. And also, there's another book over here, which is only a reference. It's called Touch of Class, Learning to Program Well with Objects and Contracts. So that one would be, if you're not so comfortable with the basics of IFO, that's also a textbook on object-oriented programming in IFO. You can also refer to it. And again, that one there is available through the through the library. So you can just go to Stacy Library account, and then you can find it online. It's also free. Okay, no need to purchase. There's another book over here. It's called Design Patterns, Elements of Reusable Object-Oriented Software. So for this course, number one, we're going to talk about contracts. That's why we are choosing IFO as a language for instruction for this semester. And number two, since IFO is object-oriented, so there are many ways of organizing your code in response to real-world problems. That's called design patterns. We'll talk about 4 or 5 design patterns, and we can go over them. However, it's only to give you some motivation to start. If you're really keen to learn about all the well-known design patterns, this will be the book to check out from the library or to buy the copy for yourself. Okay? I think they got a catalog of tons of design patterns over there that you can go over. Okay, number 3. Number 3 over here is we're going to use the bond diagram notation for drawing your design diagram. So I'll talk about bond syntax throughout the course, so you don't have to panic. I would say only refer to this particular reference when you need to. Okay? It's quite a thick book. You don't need to read it. Okay? Only make it as a reference. Now, okay, again, today we're here, and on Wednesday we'll be here. Okay? Just don't go to the wrong place. Okay? And then we got a labs, and then we got a lab test. Basically, for lab tests, we got 2 lab tests. The good news is they're only after the reading week. Good, yeah. Here's the bad news. You guys are 3rd year, right? many of you will graduate soon and then go to industry, right? So it would make sense to have a high expectation on you, which means in this programming test, if your Eiffel code doesn't compile, 0. That's a bad news. But I'm telling you in day one. So please, okay, I tell you what, since we are computer scientists, all we focus on will be computational thinking, the abstract idea. It doesn't matter what the syntax is. Java, Python, Eiffel, doesn't matter. It only takes you a few weeks to get used to it. That's why we give you labs. And that's why we only give you lab tests after the reading week. And before the lab test, we'll give you a preparation guide to know exactly what to expect. However, if you simply didn't spend effort and simply write Java in your lab test, of course you get 0, right? Okay, I'll talk a little bit more about lab tests, okay? If you really feel the pressure, that's good. That's exactly the impression I want to give to you, right? You want to take it seriously. How about that, okay? I'm sure you won't. Okay, grading scheme. We got 5 labs. Lab number 1, 3%, 3, 4, 5, 5, something like that. The reason that 4 and 5, I kind of forget, I got to check. One of the labs, you're also supposed to draw some design diagram in the bound notation. But since we'll see many examples before the lab is released, you're gonna have time to get used to it. We also have a big projects. By the way, for each individual lab is individual work. You're only supposed to work on your own. And we do check for plagiarism. Please, don't copy any code from somebody else. We do check, okay? And for projects, it's going to be teamwork, but I'll give you more instructions. You can definitely work with your classmate, that's fine. We'll give you more instructions later, okay? And then we got 2 lab tests over here, and then 10% each. And we also got a final exam. And the final exam, there will be no multiple choices, no. Okay, it's mainly a completely purely written test, which means you have to apply what you have learned and put it in words. Okay? Now, unlike what you did previously, maybe for multiple choice in 2030, for example. All right, and that's just a standard cutoff, interpretation for letter grades. Okay, so this is kind of the schedule which is consistent with the wiki. So now you can see that lab test 1 only happened after reading week. So you do have time to get used to the syntax. Okay, you do have time. And also lab test 2 and March 15th. You can mark the date down. Okay, it's going to be fixed. And one thing to note, you can see that we are now currently on the week of, so these are all Fridays. I should make it easier, which means for January 11, you should show up to the lab, which is a Friday for lab number 1. You got next Friday as well. And then the lab 1 will be due just over the weekend after that. Okay, and then we got lab 2, lab 3, lab 4, etc. Okay? All right. Any questions until now? Yes? Quizzes. You know what? There will be no quizzes. Okay, so according to the scheme, we only got either, we got lab tests, we got labs, we got projects, and we got exam. No quizzes. Maybe I'll ask Jonathan to move it. It's actually from last winter. Don't worry about it. No quizzes. Okay. Okay, now let's go to the next one. So this calendar is only tentative for section M. So as I said before, me and the other instructor from section Z, we eventually will cover the same topics to be covered in the exam. However, the way we organize the topic might be a little bit different. Okay, but you don't have to worry. Okay. Okay, any question about the syllabus? Okay, good. Let me go back to the slides and then show you a little bit more information there. Okay, so now this, for section M, this is the most important site for you to go to, maybe on a daily basis, well, at least after class. Basically, you can just click on the link, you can just go to my website, EECS3311.ca, tell the Jackie under teaching lectures, you will see there's a site. Let me just go there. So there's a website over here for our section over here. So I will post all the recording for the lecture, illustration on the iPad, and also sample source code and slides. Everything you have to study will be here. Anything that has to be common to both section M and section Z, we'll post it on the wiki. So these are the 2 sites. Okay. And now, again, for your convenience, the tutorials over here, the second one over here, will be the one you must complete as soon as possible. Okay, the one I just mentioned. And there will be others about some other design patterns and some other stuff. I'll refer you to it as we go through them in the lecture. Okay? Guys, any questions? You guys are so much more pleasant to work with than 1021 students. I'm sure you know what I'm talking about. There's not a single moment it's like this. Thank you. Okay, good. Okay, that's a website you have to check. All right. Let me see what else. Assigned readings, yeah, you can also find that. Study tips, very quickly, okay? So each lecture will be recorded entirely, but I do suggest you still come to class. The main reason for me to really record a lecture is not for you to have an excuse not to come to class, although you might take it as an excuse. It's mainly for you, since we are teaching difficult concept over here, I don't expect you to get 100% comprehension each time. If you only get 50%, that's fine. Maybe once you go home, choose the part you want to revisit. That's why I made the video available to you, okay? Okay, so now, good. Okay, general tips about studying CS. Well, I just mentioned very quickly. You know, I tell you what, I'll make it very brief. You know, I don't need to waste your time. I would say inspiration is more important than perspiration, which means spending a large amount of time on this course will be very nice and also necessary, but may not be sufficient, which means you want to know what you're doing, right? Sometimes you might spend maybe 2 hours in front of the Eiffel code and facing some code that simply doesn't compile. You simply don't know what to do. You need to ask for help, right? So my point is, when you are studying this kind of subject here, you want to make sure you really know what you're doing. You want to go over the slides, you want to go over a lecture recording, go over the labs, go over many resources, and try to reflect on yourself, what's going on. Okay, that's something you want to practice. If you need more advice, maybe speak to me, okay? I don't want to waste too much of your time. Hard work is really important, but it's not the only factor. I really, sometimes I feel very sorry to speak to students. Let's say after the exam, they told me that they spent so much time on this course, maybe much more than any other courses, but they still cannot make it. So my point is you want to stay on top of everything. But, I'm here to help you. All right, academic integrity. Okay, you can read the slides as well, but for this particular course, number one, labs are supposed to be individual work. Never ever try to share or copy the code from your colleagues. As I said, we do check. Number two, and for projects as well, you should not talk to other teams. You should only focus on your own team. And yeah, that'll be it. Okay? Just make sure you read it. Okay, one more thing before I go to the course contents. If you need accommodation, let me get to you. If you need any accommodation for your lab test, for your exam, please just get in touch with me by email, or you want to speak to me. Okay? Make sure you do this within by the end of this week, so I can arrange that properly for you. Yes.
So for the labs, you say like don't focus on health. You mean don't like share code or don't?
Don't share code. Don't share code. Yeah. Yeah, exactly. So basically, there are two reasons for that. One, if you share the code, of course, we'll catch you and then we'll accuse you for cheating, right? Number two is more long-term, because if you actually try to cheat on a small component for the course, you'll fail on the bigger component for sure, I guarantee. What I found from the students from some semester ago, I wouldn't say which semester, they asked me to check their lab test. They believe they should deserve some good marks because they got 0. I look at their code. You know what I saw? I saw basically a Java code. They basically write Java over there, and they actually dare to ask me to regrade them, right? So now my point is, you want to be responsible for what you're learning now. Don't try not to blame too much on the Eiffel language over here, which students typically do, right? Which I wouldn't blame you too much, because Eiffel is like a new language to you. You have to spend some time learning it. The best way to learn it, labs, right? I guarantee if you really spend a good amount of time, by the end of the second or third lab, Eiffel should not be an issue for you. So you can focus on many more interesting concepts, which you just cannot do in Java. That's something I will try to convince you for the first lecture. Again, this is a university. You don't have to agree with everything I say. Feel free to disagree. But the bottom line, we use Eiffel in this course, right? That's the bottom line. All right. Okay, guys, any questions before I go to the course content, the first lecture? Any questions? Yes?
Do you post the slides before class?
You know what? I will try to post the slides before class, but I would say at least maybe shortly after class, I will post them. It could be that maybe I post a very long slides, Maybe I couldn't finish that this time, but next time you do have the access to the rest of the slides, right? Yeah, I'll try. Yes?
So how do you recommend preparing before class just to be ready? Like, what do you recommend us studying?
Well, so the question was, how should you prepare before the class? Ideally speaking, even myself didn't do it when I was a student, okay? Ideally, okay? Well, when I was a student, my professor didn't really make video recordings available to me. I wish they did, but no way, right? Okay, this is what I would recommend if possible. Number one, during the lecture, try to engage as much as possible. If there's really a particular point you really just cannot get it, make a note to say, okay, maybe around this time, Jackie talked about something I simply don't understand. Maybe it's just too fast. And then when you go home let's say you do before the next lecture, try to watch that part of the recording. Try to see if it makes sense out of you when you don't have time pressure. If still doesn't make sense, it could be that I did a bad job. Well, talk to me during my office hour, right? You don't want to talk to me only before your lab test or before your exam. It's too late, okay? Lecture is number one, okay? Number one important thing. And for the labs, you also want to start as early as you can, and then try to see all the issues that you're facing. Maybe talk to me during a lab session, labs and lecture, okay? If you can at least finish these two, I don't see any reason you wouldn't survive, yeah. Okay, any more questions? Good. Now, let's now go to our very first lecture for 3311, which ironically, we wouldn't show any iPhone. Design by contracts. Here's a roadmap for the lecture. We may not be able to finish that completely today, but I'll definitely finish that by the end of Wednesday. So next week we can start talking about more specific concept, okay? Basically what I want to do, I want to first of all tell you why software design is an important course. Number two, why do we choose iPhone as opposed to using Java, which you're pretty much familiar with from 2011, 2030. There's a reason for that, okay? It's not just because we like iPhone. It's not very academic reason, right? Everything must have a rationale. That's the rationale I'm trying to convince you. Again, you don't need to be convinced, but at least I'll make an attempt. Okay? What I would like to do now, first of all, I will talk about design, what design is in general. And then I'll give you some judging criteria to see whether a particular language should be a good design language. Java versus iPhone, for example. And then I'll try to solve a very small design problem together with you. Bank account, as easy, cannot be simpler. We'll try to solve that in Java, and we can see how ugly or how inconvenient it can get into based on what you learn in 2030. And then I will show you what the corresponding code or design will look like in iPhone. You will see why iPhone will be a much better language, not for implementation, but for design. That's really the thing I would like to carry out first, okay? Now let's give some motivation. So why do we have to bother about design? Why don't we just take another, maybe 2012, like a 2011, the next course, like advanced data structure algorithm, right? Why do we need a design course, okay? There are many research literature over there simply tell the following. Okay, I'll just cite one paper for you. You don't need to read it, but I'll just give you a reference if you're interested. So now, if you work as a software developer in Google or in Microsoft, right? So now if you work as a team, intuitively, tell me something. You got different phases for your developments. You got requirements, which means you have to elicitate the requirements for your customer to get exactly, to know exactly what they really want to build for their product. That's so-called requirements. If you're interested, 4312, that's a course you can take later, okay? Requirements, and then design, which means you try to figure out exactly maybe what's kind of the architecture between the modules and what should be the behavior for individual functionality for the module. That's design. And then you move on to implementation. What's implementation? Exactly what you learned in 2030 and 2011. Okay, we got requirements, we got design, and we got implementation. You also got deployment, also release, right? Many phases. Intuitively, if you're destined to actually have an error in your projects, which phase would you rather it occur? Would you rather it occur in the deployment phase, or would you rather it occur in the requirement phase? Think about it. I'll make it more visual for you, okay? What I'm trying to say over here is, let me just add a new page over here. So basically, if you talk about the flow of development, okay? So now we have requirements, and we have design, we have implementation. I'll make it a little bit simplified. What about deployments? Deployment means you make it maybe deploy in the target system, okay? Requirement is you want to go something from informal from your customer to something maybe that's a little bit more computable, okay? And now for design, you want to figure out two aspects. Number one, you want to figure out what's the architecture among your modules. For example, how many classes do you want to have? And for each class, how many methods do you want? For each method, what kind of signature would you like to design with the method? You know, stuff like that. Design and also architecture and also specification. And for specification, I will leave it just question mark over here. I'll give you a little bit more example in a moment, okay? Now, implementation is exactly what you're very good at before coming to this course. Everybody completed 2011, right? That's exactly what you learned in 2011. Basically, you talk about efficiency. Oh, sorry. Efficiency over here, you want to have a very elaborate data structure. So you wouldn't really want to use, let's say you want to implement a dictionary. You'd rather use a hash table as opposed to two arrays, right? Something like that. That's some judgment you have to make. And deployment, it's, you can think about whether it's going to be Windows, or it can be maybe a Mac, or like a mobile, like a tablet, what you learned in 2022, right? Seriously, any one of you still remember how to develop an app in Android? Up to now? Nobody, right? Good. That's a problem. That's a problem, you know. Not you guys' problem. You know, I mean, the curriculum's problem. Anyway, you guys are fine. You guys are fine. You guys are so quiet, which I like a lot. Okay, requirements, design, implementation, deployment. Now, here's my question. Intuitively, if you're destined to have an error, for sure, would you rather you discover the error over here, over here, over here, or over here? 1, 2, 3, 4. Which place would you rather the error occur? And give me some judgment, like take an educational guess, and then tell me why you think it should be rather there, rather than the other 3 places. Yes? Requirements? Why would you think so? Mm-hmm. Yeah, exactly. Okay, so now the answer is this: as early as possible in your development process. Okay, for example, let's say this. If you only found out the error over here, let's say, you only found out the error when you get to the implementation over here. The error may not be as easy as this, maybe some bug on your hash table implementation. May not be that, maybe more than that. Maybe just the way you actually think about how the methods should work together is simply wrong. So that means you may have to trace back to the design and change the architecture, change the specification. Not only that, you also have to go back to the requirements, talk to your customer to ask them, oh, is this really what you meant? So many things involved, which means the later you discover the errors, the more things you have to check backwards, back to the earlier stages. Okay, so now, specifically, having this in mind, in this course, we're learning design. Previously, you learned about implementation. What we want to show you in this course is to have the right level of abstraction so that you can have a good design. Once you have the good design, everything else would be just to elaborate the design into some efficient data structure. Okay, that's something we want to get into for this course. Okay, let me show you some slides. Okay, again, if you're interested in requirements, we do have it, EECS3311. Okay, very good course. I didn't teach it. You know, I'm just saying it's a very good course. Okay, so now let's go over. Okay, basically I said already. You know what? basically the cost, the later you discover the error, the cost will increment exponentially. So this requirements, design, implementation, release, and now as early as possible. This is some figure which I cited from one of the IBM white report. Okay, I will include references for you at the end. You can look at that. So now, let's try to understand this diagram here. This one is saying the following. Design phase, implementation phase, integration testing, and also beta test, and also deployments. Basically, if we say that the cost of fixing the bug at the design level is 1, okay? If you actually only found out the implementation part, the phase, which means already late, is already 5 times the cost. If you find it even later, let's say all the way until the release, is 30 times more cost. You don't want to give a buggy software product to your clients, in which case you'd be too much costly to fix it. All right? Everybody got the point? My point is, you'd rather discover the error in the design as opposed to the implementation to save cost. What's the consequence of this? The consequence is, for this course, if you really want to learn about how to write or construct design properly, the media is very important. Media will be a language. Now the language, now here's a question. Should we use Java, right? That's a question. Because you know about Java already, it will be very convenient. We don't have to have you learn the new syntax for Java, any new details about Java, right? But now the question is Java really a good language for you to learn design, right? That's something we want to find out. Okay, so now, choice of design language is actually very important for this particular course. Okay, and there's a link over here. You can feel free to explore that for the white paper. Okay, what is this course about? Let's just talk a little bit about design, and then we'll try to judge how inappropriate Java might be. Don't get me wrong. I'm not trying to say Java is a bad language. I'm saying the following. Java is simply not appropriate for design, but it would be a very good choice to have Java for implementation. Okay? That's something I want to say. What is this course about? Design, of course. Otherwise, we would have called that software implementation rather than software design, right? Now, there are 2 parts for the software design. Architecture. So now for the architecture, basically there are 2 things let me briefly speaking in your Java terms. In your 2030 and 2011, there are 2 kinds of architecture you might have. Either association, which means you can declare attributes of certain type, right? That's so-called client supplier, which I'll give you an example a little bit very soon. And the other one is called inheritance, which we also learn about. Okay, so these are 2 typical architecture you want to have. And also specification. Now, specification is really something you cannot really do properly and precisely in Java. Okay, specification is about a precise functional interface of each module or each class. When I say functional, I mean functional, which means it's not just about signature of your method. You want to really say, based on the interface of this particular method, I want to know exactly how it is supposed to work. For example, if I tell you this, I'll give you a little bit challenge. You learn about topological sort, right? Do you know what it is? 2011, topological sort? I hope, right? Let's make it easier, binary search. Okay. Now you got it. Okay, binary search, good. Binary search. Now, can you tell me a design for binary search? Oh, you know what? It's okay. You don't have to answer me now. You are not ready yet. Okay. What I'm trying to say is asking you to coming up with a good design for binary search is different from trying to implement it. It's different. Because if I want you to give me a design, I'm not asking you to give me Java code. That's not what I'm asking for. Specifically, what I'm asking for is what should be the precondition for binary search, and what should be the post-condition for binary search. Okay? Think about it. Okay? Now, I will have more examples throughout the course. Okay, so now for this course, specifically, IFO is a very good language for design, but for implementation, it doesn't have as many user library as supported in Java. That's why IFO cannot be a very good implementation language. But it's not a language that can fit them all. So for this course, what you can keep in mind is As long as your implementation in IFO works, you don't have to worry too much about the efficiency. Okay? That's something I want to mention. And efficiency is really out of the scope for this particular course. And we assume you learned them about 3101, 2011. Okay? Okay, so now having a suitable language for design matters the most. Now, here's a question. Is Java also a good design language? Java is a very good implementation language, no question about it. I'm not trying to devalue Java for implementation purpose. But what about design? Okay? Well, the answer would be, we have to understand what a good design is. And then we want to see if Java can achieve such good design. Okay? That's kind of the roadmap. Okay? So now for the next few slides, let's not talk about any programming language yet. What I would like to do, I would like to go over some terminology for design, specifically client-supplier relationship, okay, and contracts. So once we understand the basic notion about contracts, client-supplier, and then we try to solve a small problem together using Java and see how inconvenient it can be or how inappropriate it can be. Okay, that's kind of the roadmap. Now, terminology, contracts, client, supplier. Okay. Now, so these are very neutral terms, right? It's not really programming specific. It's your layman's term. Okay, contracts, client, and supplier. Now, number one, what is a supplier? I'll give you an example. Okay, supplier is simply somebody or a party that implements or provides a service. Let's say the microwave manufacturer, microwave, okay, supplier. And a client simply uses a service. And later on, we're going to apply this notion about client, supplier into the context of object-oriented programming. That's what we'll do a little later. Okay, but we'll make that connection a little bit later. And now, one thing to note, client, supplier is really a relative notion. So for me, I can be the client of some supplier. I can also be the supplier of some other clients at the same time. Okay, it's really relative. Okay, and let's say this, and the clients are required to follow certain instruction. Let's say if I want to, let's say you're the microwave manufacturer. I am the microwave user. Okay, what do you expect from me? Well, you expect me to at least follow the instructions, right? If I want to use a microwave, I better put the power on, give you something that's not explosive, and also close the door, right, when I turn it on, right? That's something you would expect from me if I follow the instructions, right? That's actually what a supplier will expect the client to follow. And symmetrically, let's say me as a user for your microwave, if number one, I close the door, I power that on, and also I give you something that can be heated, and what do I expect from you? You better be heated. You better work, right? If it doesn't really heat it, but instead it froze my kind of lunch box, I'll complain, right? Okay, good. Yeah. Good. Okay, you kind of see the analogy. Okay, so if the instruction are followed, the client would expect that the service does what it is guaranteed. Okay, a lunch box is heated. Okay, now the client does not care how the supplier implements that. I don't care how you actually implement your microwave, as long as it works. As long as, number one, you have a clear instruction for me, and also as long as it works. I don't care how you implement that. I don't care. Okay, so here's another thing you want to keep in mind. Whenever we talk about client-supplier, we talk about benefits and obligations. Okay, so now let's try to do some little bit exercise together. We got benefits, we got obligations. Okay, so you know what? Okay, good. Let's say for clients, let's say for the particular microwave example over there. So what would be let's talk about obligation, that may be a little bit easier. What would be the obligation for the clients? Follow instructions, right? Of course, the instruction must be reasonable. You cannot say you give all the physical parts for the microwave and expect the client to assemble that themselves, like an IKEA, right? It's not possible, right? You gotta be reasonable instructions. And what about the benefits for the clients? It must be, yeah. You don't have to worry about how it is made. You can just basically put something in a black box, right? And then you will expect the service to be provided, right? Okay, whatever, that's guaranteed by the service. Very good, okay? That's about the benefits and obligations. Very nice. obtain a service like a microwave, heating the lunchbox, and follow instructions. By the way, obligations in this case is the precondition. And benefits over here is a postcondition. I'm trying to link a little bit to the programming, a little bit. What about supplier? What would be the benefits for the supplier? Huh? He sells it. Yeah, apparently he sells it, but he sells the service. Well, true. Benefits, you know what? Not really from a financial point of view, right? Benefits more from if, let's say this, if I'm taking something from my clients and I try to heat it, what's kind of the benefits I can have? Do I have to do lots of work? What kind of assumption can I make? That's kind of the benefits I'm trying to do.
Freedom of implementation.
Freedom of implementation, I agree. It's benefits, which means you don't have to reveal any design decision to your client. I agree. Not the most critical one, but it's a necessary one. Yes.
So are you asking about
The benefits. Let's do benefit first. What are the benefits for supply? The main benefits. I'll give you a little bit hints. Look at row number 1. Yes.
we can assume that the client follows the
Aha, exactly. Which means the benefits for let me take your row for now, okay? So let's say I'm the microwave manufacturer. My benefits is whenever I take any stuff from you, I can assume at least it's not an explosive. And then I can assume that you always close the door and always you'll put the power on. That's what I can assume. I don't have to worry about to really hit some explosive with the door open and with no power. That's not the kind of the magical microwave I need to implement. No. Okay, that's my benefits. Right? And what about obligation? One thing to note, you can see that over here, you can see the supplier's benefits is exactly the obligation for the client, right? It's completely symmetric over here. Okay, now given this, what would be the obligation for the supplier? Exactly, and then you got to provide a service, right? So you can see the obligation for the supplier is exactly the benefits for the clients. So now that means they got some mutual agreements over here. My obligation is your benefits and vice versa. Okay? Yes? Is the client's post-condition at the same time the precondition for the supplier? You're asking the following, right? I would say yes, but it might be a little bit too difficult to really imagine this without an example. Yeah, I will talk a little bit later. Okay. Guys, any question about this table here? Okay, now, in some way, this table here forms the basis of a contracts. Contracts, okay? There's a contract over here between the two parties. Now, how can a contract be violated? Right? A contract can be violated by either party, right? Can be either violated by the supplier or by the clients. Give me one example. How can a contract be violated by the clients?
If the client does not follow the
Exactly, if they simply put in some explosive, right? And so if that's exactly right, so it can be violated if the instructions are not followed, right? In that case, client's fault. In programming term, precondition violation at the runtime, which you might have seen a lot in your labs, I guess, right? Now, if the instructions are followed, but the surface is simply not satisfactory, freezing the lunchbox as opposed to heating it, right? In that case, that would be the supplier's fault. Okay, so these are the typical ways when the contract is violated. And now here's the thing. What is a really good design, which I will enumerate in the next slides. A good design, number one, you must be very clear about who the client is, who the supplier is. You must be very clear about what the benefits and obligations are for both parties. And number three, you want to make sure when you try to execute a contract, if there's anything that goes wrong at the runtime in programming term, it's got to be exactly one party to be blamed. If something goes wrong, you shouldn't say, oh, it's both parties' fault. It's not good. It's either client's fault or supplier's fault. Okay? That's how you judge if a design is good or bad. And now we want to see if it can be nicely reflected in Java or expressed in Java. We'll get there. Okay, so now let's talk a little bit more about some example over here. So what I would do is I will give you some sample code to go over. Okay, let's go over together. By the way, it's Java. Okay, so don't tell me you cannot read it. Okay, well, it's possible, right? Maybe you're so much into iPhone already, right? You cannot recognize Java anymore. Maybe, I hope then I'll be very happy, right? Okay, now we have a class called microwave over here, and we got on and locked, two attributes here. And we have a method mutator called power that on, set it to true, and also lock it, set it to true. And also we got, for microwave, there's a heat method, okay? Simply mutator. And then it's going to take some input arguments, any objects. We simply don't know what the object is, some stuff, okay? And then some implementation here, which we don't have to worry for this example. Okay, that's about the microwave class. And now let's say we have another class over here called microwave user. Okay, and then we simply, let's say main method, doesn't matter. Okay, so now let's see the following lines of code. It's really important to see this is a typical scenario where you can identify who the client is and who the supplier is. Okay, now as soon as we have this line over here, so you can see we are declaring an object M of type microwave. And then we have microwave over here. Basically, every time when you try to do a declaration, in this case, you're declaring an attributes. Or in more general sense, which we'll see later, if you're trying to declare an input type, or you're trying to declare some return type, every time you have such declarations, that means you have a so-called client-supplier relationship. I'll illustrate that here, just by this line. So this line over here already suggests a client-supplier relationship. And relation. Okay, intuitively, can you tell me who you think is the client and who you think is the supplier? Yes. The supplier is a microwave. How do you figure? How did you figure? Okay. I don't want to be too harsh on you. Okay, yeah, actually you're right. Well, also based on our discussion previously, of course, microwave gotta be the supplier, right? Okay. Now, thinking this way, let's look ahead a little bit further. Okay, of course, you can actually try to. Let me just only look at this line. This is a critical line. If you look at this line over here, it's a method call. This is the context objects over here. Okay. Context objects, as we learned from 2030. And this is a method that we're trying to call on this particular context objects. More generally speaking, you can think about this as a service that we're trying to call. All right? And this object over here is the input that passed to the service in order for the service to be provided. So from that, we would know the type for the context objects is the supplier. Because whatever heat operation that we should really be executed is defined in the supplier class, which is the microwave, right? In this case, do you follow? Okay, because N was declared to be a microwave over here, right? It's a microwave. And microwave provides the surface called heat. That's why it's a supplier. Okay? On the other hand, how do we know that microwave user is the clients? It's simply because we are trying to make this particular method call in the context of this class. That's how we can call that a client. Which means in the microwave user class, we're trying to make use of this particular surface. Okay? Now, how do we make this a little bit more simpler for you to understand? You want to draw some diagram. Okay? Here is the number one bound diagram notation you can learn. How do we represent classes? We use oval shapes. Okay. First of all, let me draw oval shape over here. You will see more in your labs. So I'll put microwave user. Okay, microwave user, and then we got another class over here. It's called microwave. And according to this declaration, and according to this particular method call, we know that in a microwave user, we are trying to make use of the surface of microwave. Now we have to show the dependency. Is it a case that microwave user depends on microwave, or microwave depends on microwave user? One or two? 1, right? Good. Microwave user depends on microwave. That's why we draw an arrow like this. Okay, it's a client-supplier arrow. And then more specifically, since we know that microwave user declare an attribute called M, so we put M over here as a label, which means in the microwave user, we have an attribute M of type microwave. Okay, that's the number one. That's just the first, your very first bound diagram to look at. So now for this course, I'll try to emphasize as much as possible diagrams, because to learn about design, sometimes you don't have to worry too much about implementation details, sometimes, right? Especially when we learn about design patterns. We usually introduce you first by design diagrams. Okay, any question about this? Okay, yes. Previous slide, yes. Yeah, go ahead. You mean the fault? Yes. Well, somehow basically if there's an error, you want somebody to be responsible for. You want somebody, not everybody, right? So which means if there's anything wrong that goes wrong at the runtime, you want to know, should I fix this particular client or should I fix this particular supplier? You don't want to get a message that you want to fix everything, right? That's kind of the intuition, yeah. Okay, guys, let me ask you another question over here, right? Now, everybody comfortable so far? Okay. Now, what I want to do, this diagram is kind of polluted. What I want to do is, at the page below, what I want to do is the same diagram over here. I want to ask you the following question. Okay. Now, again, focus on this line over here. Remember, we talk about benefits and obligation, right? Okay, now, let me give you a little bit hints. Before we try to make this particular method call, there are two timings over here, before or after. Before we try to make this method call versus after we try to make this method call, okay? Now, can you try to explain to me, based on the code over here, do you think the client is following the instructions? Let me say it again. Look at this one here. Okay, look at this point here, right before we try to call m.heat, right before that, okay? So now the question is, has the clients followed the instructions? Okay, that's question number one. Okay, I'm talking about this particular point right before we try to call the method. All right, number one. Question number, I'll post both questions at the same time. And now, question number two. Let's focus on after this method is called. Okay, I'll put it here. Okay, that's question number two. Has the supplier fulfill their obligations? Okay, so these are two questions over here for you. Okay, let's do question one and then question two. But I'm trying to say there are two timings you have to consider, before the method call and after the method call. That's my point. Okay, let's talk about Q1, before the method call. According to the code at the moment, can we actually tell if the client has followed the instructions? Can we tell or not? Yes or no, basically? No. I heard no. Why do you think it's no? Well, let me just interrupt you a little bit. Well, we can see that, let me give you a little bit hints. We can see that in the context of, remember this is a client, right? In the context of this class, we try to power on the microwave. We also try to lock the microwave before we try to call this method here. It seems like the client has kind of followed the instruction, right? But what's missing here if you said no?
We're not sure what the object is.
Yep, exactly. We're not sure what the object is, right? So that's why I put the question mark over here, which means it has to further to some checks. which means as part of the precondition for heat. Okay? As for part of the precondition for heat, you have to also check on the objects. Okay? I'll just make it a little bit informal here. Okay? That's about question 1. So the answer is no. Actually, we should say we don't know. We don't know because objects is uncertain. Okay? We don't know yet. Okay? You must check it at the runtime. What about question 2? Has the supplier fulfilled their obligations? We also don't know, okay? Because, well, object the object over here, the object over here is the input to this particular service. So the input is the responsibility for the clients. Now the output will be a responsibility for the supplier, right? So now, one thing to note, you can see that in my Java code over here, I do have something over here. You can see this is the service over here. But now, if I am the client for this particular service, if you use JavaDoc to generate the API, the only thing I can see is void, hit, object, and stuff. I have no idea what this method is supposed to do upon the execution. As part of the interface, it's simply not clear what would be achieved by the heat. Okay, I'll just say it over here. As part of the API of this method, not clear about what will be achieved. It's simply not clear. It would be very nice if we can have a post condition over here as part of the interface to tell you that if you try to heat, what the post condition might be. Maybe objects that heat would be true, something like that, right? Okay. So this is a very informal discussion. I just want to get some feel. Every time when you see some method call in object-oriented programming, think about before the method call and after the method call. Okay. Before the method call, it will be the client's responsibility to establish the precondition. After the method call, it will be the supplier's responsibility to establish the post condition. Okay? Yeah. Oh no, nothing. You're talking about this void over here? Nothing to do with void actually, because void simply means you don't really return anything. That's okay. Yeah. When I say output, I don't necessarily mean a very restricted notion about return of value. When I say output, simply output states for your objects. The output can be maybe you modify some part of your object attributes to some other value. That can be also an output. Okay. So what's really lacking here for the microwave, the heat is, first of all, you can see when we say assume. Oh, it's good that I actually also mentioned this. If you look at this particular assume over here, we put it into comments. That means the supplier of the heat, they're assuming that whatever whatever input object that's being passed over here must satisfy these conditions. Are there going to be any checks at the runtime though? Of course not. They're only comments. Comments will just be ignored at the runtime, right? You want to make sure, number one, you can specify precondition, postcondition as part of your programming text, number one. Number two, you want to make sure whatever pre and post condition you actually specify, they can be enforced, they can be checked at the runtime. So these two things. You can only do these two things to a very limited extent in Java, which we'll see from a small example. Okay? You want to be able to specify pre and post condition, you also want to be able to check automatically, okay, at the runtime. Any questions up to now? Okay, it's a very general discussion, but it's worthwhile. Okay, let's go on to, so that's basically about microwave. Okay, you can go over the rest. Okay, before the method call, after the method call, okay, and also we'll talk about contract violation. You can also have a look at that. Okay. By the way, there is, for your benefits for this course, maybe I'll try to give you a little bit more details. We talk about how you can specify design in an appropriate fashion. In order to do that, you must be precise. In order to be precise, you need to be mathematical. So for this course, you must make sure you review some concepts about discrete math, 1090, 1019. Okay, maybe a long time ago, I know, but review that. Especially what's implication. You know what the implication is, right? Maybe we'll do some example a bit later for you. Okay, universal quantification, existential quantification, stuff like that. Set membership, set union, set intersection, stuff like that, right? And for your lab number 1 and 2, you will see there's a library called math models. That's exactly the library that's good for the design purpose. Okay, so that's something I want you to try to review the stuff, for your own purpose. Okay, good. Let's go on. So what is a good design? Okay, let's go over this slide and then we'll do Java. Do one example together. Okay. So what is a good design? A good design should explicitly, which means it should be part of the programming text. It shouldn't be just a comments. Shouldn't be. Okay. Comments will just be ignored by your runtime execution engine. Unambiguously, which means it must be very precise, telling what's exactly is being expected. Okay. Describe the contract between clients and the supplier. Okay. And we already know what the clients are and what the suppliers are. And we call such contractual relation as specification. Remember what the design is in the previous slide. 2 parts. One is about architecture, either client supply or inheritance. And the second part is specification, which means you want to be clear about what the behavior is for each method. And behavior will be precondition and postcondition. Okay? Okay, when you conduct software design, you should be guided by the appropriate contracts, which means when you're, let's say later on when you do your projects, even for lab number 4. Lab number 4 is going to be very interesting because we give you what should be expected, but we don't tell you what classes to make, right? That means for you as a designer, you have to come up with all the classes that's necessary to implement the requirements, okay? That's kind of the thing. You want to say, oh, should I do client supplier here? Should I do inheritance over here? Well, what kind of precondition and postcondition should I have? That's the chance for practicing. But before that, you have to get familiar with IVO syntax. But okay, the instruction for client should not be unreasonable, which we talk about. You want to make sure you don't really ask the client for the microwave to assemble the parts themselves, right? That's not right. And also, the working conditions for the supplier cannot be unreasonable either, right? You gotta be fair. Okay, that's also the example we talk about. Okay, so now you should really have a proper balance between obligations and benefits. Okay, so now, question for you. What is the obligation of a binary search user, not implemented user? What's the obligation? What's the input for binary search? Input first, yeah, with a sorted array. Okay, that's very good. You pretty much say 2 things, okay? The input to a binary search is an array. And the precondition for binary search will be the array is sorted, right? Okay, that's a very simple example. Okay. Actually, I will have that. Let me talk about the example a little bit later, okay? Binary search. Okay, the input array is sorted. And now you want to make sure a good design means, like what you ask, we want to make sure if there's anything wrong, we actually don't blame on everybody. That's not very helpful. You want to have exactly one side to blame, okay, so we can be more focused. Okay, it's called design by contracts. So that means design by contract is really a judging criterion for us to see if Java is a good design language. So now, in the next 15 minutes or so, and for the next lecture, I will try to do a little bit design by contracts using Java, based on what you learned in 2030 and 2030, just using some exceptions, assertions, stuff that you have been familiar with already. Okay, let's try that. Now let's have a very simple problem to solve: bank accounts. Okay. Let's say we want to, we'll go over the requirements for the problems, and then we'll focus on only 2 of the requirements. Requirement number 1, okay, maybe try to memorize the requirement if you can. Okay, only 2 requirements you gotta memorize, okay? Each account is associated with the name of its owner and an integer balance that is always positive. Okay, positive, important. Okay, requirement number 1. Requirement number 2, we may withdraw an integer amount from an account. One thing to note, this is exactly how the requirements might look like. They don't seem to be very complete. They don't seem to be very clear. There might be some missing details here, but that's okay. It will be your responsibility to actually somehow translate these requirements into some design. Okay? Okay? Requirement number 1 and number 2. For the rest of the slides, we're going to focus on only implementing these 2 requirements. You can already get a giant piece of Java code that is not so easy to follow already. That's my point. Okay? Even those simple problems. Not to even mention if you have a big project. And of course, for your interest, you can feel free to actually look at other requirements if you want as a practice. Okay? But actually, if you try to follow the bank account tutorial, which I just mentioned in the beginning of the class, it does go over all the requirements to see how you can do that in iPhone. Okay? Now, let's now work on requirement number 1 and requirement number 2. Okay? And now, they may already not be as easy as you might think. Okay, let's have a look. Okay, the source code is made available to you. You can go to my lectures website. I'll post them after today. You just have that. You should have to import the projects, and then you have to enable the assertions checking in Eclipse. That's also I got a tutorial video for you for your interest if you want to play with it. Okay, we're going to look at different versions for the Java code. We go for the most intuitive version, criticize on that, make some improvement, criticize on that, make some improvement, until we get to something that would seem to be acceptable as a good design. Okay, that's what we want to do. Version number 1. Okay, we have an account class. Okay, let me just go over the class with you, and then we'll try to criticize on that, right? Okay, well, let me just check. We have 8 minutes, maybe? Okay, I just want to make sure. Yeah. Good. Yeah. So now we got 8 minutes. At least we can go over version number 1, at least. Now, let's go over the very first version very carefully because other versions look kind of the same, maybe a little bit similar. Let's say account v1, version 1. We got 2 attributes. We got string owner, we got integer balance. For the simplicity, let's say balance is integer. Okay. And then we got get owner, get balance, easy. And then we got constructor over here. We got owner, we got balance, okay? And then whatever the user pass as owner, as balance, we simply assign them. Looks reasonable, okay? And hopefully, you also know about how to use this, right? Okay? And then, line number 9, we got withdraw, which means whatever the user wants to withdraw, we do it. Whatever the user wants to withdraw, okay? I'm not sure if you see my hints. Whatever the user wants to withdraw, okay? Whatever they want. Okay. Sorry. Yeah. And to string. All right. Now, anybody wants to criticize on this first version over here? Okay. We got several criticism that we can have. That's version number 1. I'll go with him first. Yes. Go ahead. Just give me one. Okay. Just one. We want to give other people opportunities, right? Give me one example that would be very bad.
Let's say you have $1 and you withdraw $1 million.
Okay, you have $1, but you want to withdraw $1 million. I agree. Okay, that's problem number 1. Simply, you want to withdraw something that's way beyond your capacity, right? Your current credits, number 1. Oh yeah, so which means you're talking about a constructor, right? You can see, okay, let me just go over here, okay? The problem number 1 that you guys discovered was, because withdraw whatever, you can withdraw maybe $1 million when you have only $1, right? And also over here, for the constructor over here, you might say minus $1 million, right? That's also a problem. Oh, thank you. Yes. Yeah, you gotta keep reminding me. Sometimes I do forget, right? Good. Okay, so these are the 2. Problem number 1, you got $1 million over here to withdraw when you only got maybe $10. And over here, number 2, when you want to initialize something that's a minus, there's another problem, at least.
If you withdraw a negative amount, you're going to add money into your account?
Oh, yeah. So that means at the moment, it's actually a very good bank. I can withdraw minus $1 million from my account. If you know such a bank, let me know. Okay? Minus $1 million. Good catch. Very good. Okay, yes, any more? Oh, absolutely. I agree with you. It should be double, even. The type. I'm just making it simpler, just integer. Yeah, absolutely. I agree with you. Yeah. Yes.
You don't check in the stuff, you don't check for the empty string, so it might not.
Empty string. Yes, I agree with you. Yeah. Of course, the owner over here, even though it's not really my slide, but I absolutely agree with you. You might want to say the owner over here is a string. You might want to say it's not empty. It is not the case that it is empty. And also, you want to say it satisfies some regular expression, right? It must be maybe capitalized or something. Okay, good. Okay, so at least 3 problems over here. Yes. Aha. Yes. Yes. So your observation is maybe the balance must be always positive. That has to do with maybe the first problem over here, which means you shouldn't withdraw more than you can afford, right? It's similar. But I agree with you. Yes. Yes. Can the owner? Oh, yeah, exactly. You talk about the kind of the pattern for the owner name, right? That's something we can do. Maybe it's kind of outside the scope for this example. But I agree. By the way, how many of you have not taken 2001? I don't think it's a prerequisite, right? But it's good that every one of you has taken. Do you know what 2001 is? The automata course, right? Theory of computation, fairy godmother. I took with the same instructor 10 years ago. Well, actually more than 10 years ago. Yeah, anyway, it's not important. All right, let's go over these problems very quickly, okay? Very quickly. What can go wrong? Problem number 1. Let's say we are trying to create, using the new keyword here, if we say minus 10, at the moment there's no check, right? You simply say Alice's current balance from the console will just be minus 10. That's apparently wrong, even though there's no exception, okay? That's the problem number 1. Problem number 2 over here, let's say we initialize Mark with a positive amount, but we do something that's really to his favorite. Withdraw minus $1 million. After that, he got this much money. Right? Okay, that's not good either, okay? That's also, you can see so far there's no crash, there's no precondition or postcondition violation. But apparently the behavior of the system is wrong. Somebody gotta be blamed. Somebody, okay? We'll get there. Number 3 over here, so now we have, let's say we have, okay, you can see this is a positive 100, and then we try to withdraw 150. That's also positive. But the problem is, after withdrawing 150 from 100, you got minus 50. And let me remind you, this will violate requirements number 1 over here. Every account has an integer balance always positive. And one thing I want to draw your attention to before I let you go, okay? So every time when you see any requirements for your particular class, let's say this particular condition must be true for every instance of this particular class. Let's say account. Every account must have their balance strictly positive. This will be a very good candidate to be the so-called class invariance, which we'll start with on Wednesday. Okay, I'll see you on Wednesday.